Hello, kiddos. Today we will be talking about writing linear equations. A lot of this will be a little bit of a recap from 3.0, and we have been practicing every day. So I really want you to focus on understanding at a deeper level and not just going through the motions. So the one thing that will really help you remember and understand this long term is understanding why all of this happens. So let's just review a few formulas that we have. So equations in standard form. So today we're all talking about linear equations. So standard form linear equations are in the form ax plus by equals c, where a, b, and c are integers. We can take any equation in standard form and turn it into slope-intercept form, which you are very familiar with from Algebra 1. So slope-intercept form is y equals mx plus b. And I know it's crazy, but you need two things. You need the slope and you need the intercept in order to be able to do slope-intercept form. The next one is the slope formula. So what if I just need to find the slope? So in order to use the slope formula, you need to have 2 points. And remember, it's arbitrary which one's the first point and which one's the second point, because I could give you the points in either order. So the formula for slope is m equals change in y, y2 minus y1 all over x2 minus x1. And if I had to warn you of one thing, just really watch out for signs. So if there's a consistent mistake that students make over the course of year after year after year, it's going to be signs. You can take the slope formula, and if you take that slope formula and you multiply each side by x2 minus x1, so we come in here and we multiply this by x2 minus x1, that's really where point slope formula comes from. So point slope formula says, all right, those two things cancel and leave you with y minus y1 equals your slope times x minus x1. So the point slope formula, you really need two things in order to execute point slope formula. You need the point and the slope, but really it's not a new formula. It is just a variation of the slope formula, which you guys are actually really pretty good at. So now I'm going to take you through a new transition that will help you as you progress to Algebra 2 next year. We're going to solve this point slope form for y. So I'm going to take this y1 and I'm going to move it to the other side. So I have y equals slope times x minus x1, and then I'm going to move the y1 to the other side. So this is a formula that we call HK formula for basically the rest of your math classes. And what we're going to do is we're going to take the slope out and we're going to replace it with the variable a, which we think of as a vertical stretch or a vertical compression. And we are going to take HK and we were going to replace x1, y1, sorry about that, x1, y1 with HK. So we can think of this formula as y equals, I'm going to take slope out and think of it as a vertical stretch or vertical compression. And then we're going to have x minus h plus k. So when I think about this, the point that I used for this formula was really slope is just a, and the point I used was just hk. All right, so that's the foundation for the rest of this lesson. So let's see where this will take us. Okay, so when I talk about thinking about things on a different level, I want you to think about horizontal lines and what axis they cross. It's very easy to think, all right, you know what? I have a horizontal line right here, cross x because it's horizontal, but really horizontal lines will cross the y-axis. Therefore, they're always going to have an equation that's y equals any number. On the flip side, a vertical line will always cross the x-axis, and as a result of crossing the x-axis, vertical lines always have an equation that's just x equals whatever value it crosses at. So now let's think about a horizontal line and the slope. Why is the slope of a horizontal line always going to be 0? So why is the slope 0? Well, let's think of a horizontal line. So let's just graph us a horizontal line. And I'm just going to pick two arbitrary points. So I'm just totally making these points up. Let's say we have the point 4, 3, and we have the point negative 5, 3. So if we go through the whole process of finding slope, the slope is going to be y minus y, 3 minus 3, all over x minus x. And when we do the math on this, we end up with 0 over 9, and 0 over 9 is going to give me 0. So if you think about rise over run, which is how many of you learn slope, if you go from point A here to point B here and you think, well, how far do I rise? You do not rise at all. So because this has a rise of 0 and I have a 0 in my numerator, it doesn't matter how far you run. You can run left and right all you want to, but if you don't rise, your rise is going to be 0, your change in y is going to be 0, therefore your slope is 0. However, let's think of what happens when I have a vertical line. So again, I'm going to draw me a vertical line and pick some arbitrary points. And when I do that, let's just say we have some point 5, 1. And down here we have some point 5, negative 2. I can think of this visually or I can think of it analytically. So if I think of this analytically, slope equals y minus y, 1 minus a negative 2, all over x minus x. So I end up with 3 over 0. And you cannot divide by 0. If I give you a birthday cake and I ask you to cut your one huge birthday cake into 0 pieces, you cannot do it. Because once you make the first cut, you get 2 pieces. If you make another cut, you have 4 pieces, and so on and so forth. Therefore, division by 0 is undefined, which makes the slope of all vertical lines undefined. If you think of this as well as rise over run, you can rise all you want to, but you cannot run. So I don't care how far up and down you go. You can go up and down all day long, but you cannot run left and right. So since your division by 0, your 0 is in the denominator, that's what causes vertical to be undefined. All right, the other thing just to think about, because sometimes they will definitely tell you about the y-intercept, and sometimes they give you points like 0, 6. So when our x-coordinate is 0 and we think about the location of the point 0, negative 6, this is really just a y-intercept. And we all know that using point-slope form is way fast, or slope-intercept form is way faster than point-slope form. You could actually use either form on this, but if you recognize early on that 0, negative 6 is a y-intercept, then that will be super helpful. All right, so we have quite a few examples on this because I don't want to miss anything, so let's start doing them. All right, so just a side note for you guys to keep in mind right here, that if an equation is in standard form, you can also always solve the equation for y and write it in slope-intercept form. All right, so sometimes that will help you when you're graphing, sometimes it won't, but go from there. All right, so example 1, write a linear equation through 0, 8 with slope 9, 2. If you look at these and you recognize that this is a y-intercept, you realize that you have the slope and you have an intercept, so we can use slope-intercept form. If you struggle with this, write the formula and start plugging in things you know. So here I have y equals, my slope is positive 9/2 x, and my y-intercept is 8. So because I had the slope and the y-intercept, I was able to use slope-intercept form, and I can use that, and I have fulfilled the requirements of this problem. Okay, example 2. Write a linear equation in slope-intercept form, passing through the point negative 5, 4 with slope 5, 7. Write your final answer in slope-intercept form. So if we look at this particular problem, they gave you a point, they gave you a slope, so we have to use point-slope form. So for some of you, that means writing what you know. Point-slope form is y minus y1 equals slope times x minus x1. If we want to go from here, we're going to plug in y minus my y value, my slope, times x minus my x value. So continue to solve for y. So y equals 5/7 x plus 5. Move my y1 value over so I get plus 4. If you think about this form right here, this is HK format. So if you understand HK format, and I will do that here in a second, you would start at this step and you would be able to skip that first step because you would already have it equal to y. So if you use HK format, this value here is your A value, this is your H, and this is your K. So just something to think about. All right, I'm going to continue up here and I will work to put this in slope-intercept form. I prefer that you work on this without a calculator because you need to learn to work with fractions and be confident in your ability to do so. So y equals 5/7 x. 5 times 5 is 25, and my denominator remains 7 plus 4. In order to add fractions, we have to have a common denominator. You know that I do that using the wacky form of 1. So I have to think, all right, what do I need to do to make that denominator 1, or make that denominator 7? So if I put a 7 in the denominator, I can put a 7 in my numerator. So that is the same as multiplying by 1. 7 over 7 is 1. So I did not make my equation bigger, or my number bigger or smaller. I am just changing the way it looks. So if I can't do that in my head, 4 times 7 is 28. Remember, that's 4 over 1 over 7. So y equals 5/7 x plus 53 over 7. This step, finding the common denominator, I'm going to highly encourage you to show that. I know many of you are tempted to go and use your calculator. However, when we start doing fractions with letters that have no numbers and you're not able to go to your calculator, understanding this process will really help make your future a lot easier and brighter. All right, here we go with example 3. So example 3, I have a point, I have a second point. So I can't really do slope-intercept form because I don't have a slope and I don't have a y-intercept. Point-slope form, I have points, but I don't have slope. But if I have 2 points, I should recognize the fact that I can always find the slope. So your slope is going to be the change in y over the change in x. And remember, y is arbitrary. So if I start with this point first in my numerator, I just need to start with that point first in my denominator. So y minus y, -9, minus a -1. And in my denominator, because -9 was my first y value, I need to start with 5 minus a -2. 9 minus the minus turns those into pluses, so I get -8. And 5 minus a -2 turns into 7. And now I have a point and I have the slope. So I don't care which point you use. I think I will use the point 5, -9. And I will use the slope -8, 7. But this time I'm going to do HK format. So if I think of what is HK format? It's y equals a times x minus h plus k. And again, this is kind of where you're going to transition to in your future. So a is just a variable representing your slope. And then you're going to take x minus your x coordinate. And then plus a -9 would be the same as -9. So all the HK format really does is allow you to take a point and plug it directly into the equation, which is already solved for y. So your directions implicitly say slope-intercept form. So let's go ahead and distribute. So take a moment and distribute your -8/7. And why don't you hit pause and finish distributing and turning this into slope-intercept form. All right, welcome back. Let's check and see how you did. So we have -8/7 x. A negative times a negative will give me a positive. 5 times 8 is 40 over 7 minus 9. I need to combine the 40 over 7, and remember that -9 is over 1. So I'm going to do my favorite thing. I'm going to multiply by the wacky form of 1. Since 7 is my denominator here, I'm going to multiply this by 7 over 7. And we have y equals -8/7 x plus 40 over 7 minus 63 over 7. And when I look at that, I am going to combine those last two terms, and I get negative 8/7 x minus 23 over 7. Okay, example 4. My favorite problems, and you guys way overthink these. So write the equation of a horizontal line through the point 4, -2. So worst case scenario, if you absolutely have no idea how to do this, you're going to graph the point. So you're going to go over 4 and down -2, and you are going to draw this horizontal line. So here's my horizontal line. And if I think about what axis it crosses my y-axis at -2. Bam, you're done. And the reason this works is because if you think of this horizontal line and you think about the slope, if you think of the word horizontal, it's H period, O period, ho, 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 like Santa Claus. So the slope of every horizontal line is 0. So this would really be y equals 0x with a y-intercept of -2. And 0 times x really goes away, and that's what leaves you with the equation y equals -2. All right, so far so good. This is a section where we're going to go backwards. We are going to think of what slope did we use and what was the point we used. I think for the most part, most of you have slope down. So if we think about what's happening here, this is y1, this is x1. So if I really want to be picky, the formula is x minus, so that's x minus x1. So looking at example A, if I look at the slope, we all see that the 4/5 right here represents the slope. And the point they used for this problem would have been x is -1 and y is 9. So take a minute and work on example B by yourself. All right, so if you look at example B, this formula is a minus, so this is really y minus a -7. So my slope is right here, 5. X minus x1, so x1 is 7. And then y minus a -7. This here is a -7. And we are done. All right, so the next problems I really like for y'all to think of as the HK kind of problems. So this is A, and this is H, and this is K. And if you think of your point is just HK, and your slope is represented by the variable A. So we look at this, my slope is -2/3. My point is normally x minus 3, so x minus what number? I took x minus 3. And the formula has a plus right here, so this is going to be +6. Some of you will think of it's the opposite of what's on the inside and the same side as what's on the outside. So example D, my slope is -5/7. And this is really x minus a -2. So my h value or my x1 value for my point is -2. And my k value is -3. Right. Let's move on and talk about parallel and perpendicular lines in reference to the coordinate grid. If I think about parallel lines basically have the same slope. Okay, their rise over run has to be equal. If the rise over run was not equal, at some point over the course of time, those two lines would cross. Perpendicular lines, however, have slopes that are the opposite reciprocal. So slopes are the opposite, and some of you will call that negative reciprocal. So for instance, if you had a slope that was +7/8, and I wanted the slope of the perpendicular line, the slope of that perpendicular line would be the opposite, so negative, and the reciprocal would make it 8/7. So let's take that and apply that to problems. So looking at example 6, write an equation of a line through the point 4, -1 and perpendicular to y equals 6/5 x plus 2. So when I really think about what's going on right here, I need a slope. So the slope of the original line is 6/5. And if you guys will use really good math notation from here on out, it will really make your life a lot easier. if I want the slope of the perpendicular, use the little symbol for perpendicular with the slope. So I can tell that this is the slope of the perpendicular line. I'm going to take the opposite, and then I'm going to take the reciprocal. Now, my new line is going to go through this point 4, -1. So I can take my HK formula, and I can go y equals a times x minus h plus k. If I look at my point, this is h and this is k. So y equals my perpendicular slope, which is -6/5 x minus h plus k, and then plus a -1 would give me -1. Since this particular equation does not ask me to write my answer in slope-intercept form, I'm just going to leave my answer in point-slope form. All right, moving on to example 7. Example 7, write the equation of a line parallel to x equals -3. We are super visual people, so if you're looking at this problem and you have no idea where to start, come over here, draw the quick axis, and let's draw the line x equals -3. So I have the slope, or I have the line x equals -3 on my page. This is a vertical line, so technically my slope is going to be undefined. So I need another line on this graph where the slope is undefined. You could pick absolutely, positively any line you wanted to, and I don't care what number you pick as long as it crosses the x-axis. So right now, I want you to all write your lucky number. My lucky number is 11, so my vertical line is going to be the line that crosses the x-axis at 11. On these, I will tell you, your key to success is if you don't know what you're doing, draw a picture and reason through it. And last but not least, example 8, find the slope of a line parallel to the line containing the points -7, 2, and 5, 12. So I want you to hit pause and take a moment and find the slope of this line. All right, welcome back. So let's see how you did finding the slope. So your slope is going to be y minus y. And because I started with 2, I have to start with -7. So -7 x minus x. 12, or 2 minus 12 is -10. -7 minus -5 is 12. So my slope is 10/12. And if I try to reduce that, 2 goes into 10 5 times, and I get 5/6. Now, going back to my problem, they want the slope of a line parallel to this, so I'm going to use my symbols, the slope of a line parallel to that. You have to determine what do you know about the slopes of parallel lines. Well, they have the same rise and they have the same run, or they will eventually run into each other. So the slope of this will be 5/6. All right, this is a lot, but we have already covered a lot of this material, and you saw most of it in Algebra 1 last year, so we are really refining your skills. So have a wonderful evening. If you are really lost on any of this stuff, make sure you come to class with questions, and we will see your bright, shiny faces tomorrow. Have a great night.